Scala Time. Happy Scala Time with front-end stuff. Okay, today we're going to go madman style through building something. We're going to build a form derivation library. So we're going to be given a case class, let's say for something like a person that's going to have a name, which is a string. And what else do I have here? An email, which is a string, and an age, which is an integer. And using this person, we would like to derive something like the form on the left. And furthermore, the changes to that form should be able to alter some person variable. Here I'm using a library called Laminar, which I like a lot. And I'm not going to explain it in detail, but sort of just as I code madly through this example, hopefully some of its features become self-evident. For instance, first, we'll need ourselves a var, which isn't just a Scala var, but this special Laminar construct that will allow us to get a handle on some piece of data. So I'm going to make a person. I will make myself, and I'll even use my real email address for some probably bad reason, and put that in a var. So now we have a person var. What does this mean? Well, it means we can take the changes to this var and pipe them into something. We can get a signal of all the changes, and then I could map this person to a string and render it to the page. Obviously, this isn't changing right now, so if I wanted to, I could maybe make a button called Get Older, in which I'll take an on-click event that this emits, listen to it, ignoring the event, take my person var, update it, getting the person, which is me, copying it, taking the age of the old person, person.age, and adding 5. Now I can click on Get Older, and I get older rapidly, and now I'm probably dead. So I'll keep that there, I suppose, for later, even though it's really horribly ugly looking. But our goal here is to do the same thing, edit this person, except not with a button, but with this form. So we're going to want to connect the form to it. And eventually, we would like to not have to write this form ourselves, but generate it at compile time using some very cool techniques we'll get into. But for now, let's at least connect it manually. So I have these 3 divs with these input group classes. I have some CSS that's pretty simple just to make it not blinding. And now we're going to, let's abstract this to make it a little more readable because there's going to be some duplication here. So let's pull out each of these individual form inputs. So I'm going to grab this one. I guess I'll call it form input. Perfect, it's down here now. And then we're going to maybe take the this name, the label and placeholder, and pull this out into a parameter. As we'll call it name. For some reason it set this to an any, which it is not. This is an HTML element. And there we go, that still works. So now I can do the same thing with email and age. Delete all of this, except of course the age wants to be a number, so I can click in here and go up and down, like so, and become Benjamin buttoned into negativity. And okay, so in order to do that, we can maybe accept this thing, plot this in here, this little type, and accept this as a parameter as well. So I'll just say, well, I can't call it type, so I'll call it tipi, and we will default it to, let's say, text, and then delete it from these 2 arguments that it cleverly filled in for us. And by it, I mean IntelliJ. If you don't know these features, they're amazing. And they make you super fast. Basically, hit Control-T, you get this refactoring menu. That's a good place to start. If you don't know how to do that, you can also hit Command-Shift-A and then type in refactor. This, lots of goodies in there. So take a look. Okay, so we have our form inputs. Let's take a slight breath. Okay, and with that breath complete, we can now continue. What we'd like to do next is accept into our form input 2 things, basically a signal of text, so a signal of strings that we can use to determine the current value of the input. Let me break this out into multiple lines. And then also an update callback, so something that's going to take the string and return nothing. We'll see how to get this to work in just a minute. So here when we change the name, we would like to edit our person. We would also like the name to be representative of the person var's name. So I can say person var signal, and then I could map over it and pluck out the name field. I can do basically the same thing for both of these, except getting the email and then also getting the age and calling to string on that. As far as updating goes, we can take the new string and take the person var, update it, copy, and replace the name with the string. Oh yeah, oops, I accepted that text parameter. I may as well just add that back in now because that's missing, and I could fix that other ways, but this is fine for now. Okay, the first one is all right, and now for the second one, we'll also take the new string and basically do the same thing, except with email. And then, of course, one last time, except down here, we want to take it and set the age. So we want to call toInt on that, which might blow up, but we're not going to worry about that right now. Okay, so now we're accepting the right parameters, but we're not using them, so let's do that. So in order to update, we're going to call onInput, which is going to emit events whenever we do a keystroke. Then we can say map to value, which is going to get the current value, and we can actually pipe that right into a function, which is kind of nice. So now as I make a name change, so I can call myself Robust again, and I can make my email something more anonymous. It all works and it updates everything, so that's cool. It works there. However, this is only a one-way binding. When I click Get Older, the person gets older, but this is quickly overridden, and our form was never even populated with the initial correct values. So that's why we also have to use the signal. So I can take the value and pipe into it the signal of changes. And there we go. It actually works. So that's basically what we want, except we don't want to have to do this by hand because it was annoying to write those update and signal mapping functions, especially when they were fairly mechanical. And basically, they could all be derived mechanically. We could write some instructions and then hire probably a kindergartner to do this for us. But in order to abide by child labor laws, let's instead write a macro. And so not to continually push off the goodness of the macro magic, but in order to facilitate the writing of the macro magic, we're actually going to first need a type class. We're going to need a form type class. So I'm going to make a trait called form, which is going to accept some parameter of a. And we want a method on form called render, which is going to accept, I guess I could call it a variable because var is taken, a var of a, and then it will return some HTML element. I think we're actually going to make this a sealed trait. And let's start with a companion object and just go over some ideal DSL that we do not yet have. So what is some example DSL? Let's say we want to create a form of a person. I can, I guess, import that person because I didn't put it at the top level. If we want to make a form of a person, how can we build this? Well, let's say we started from some primitives. So let's say we had an int form. So we could have a form of int, and we could also have a form of string. And these were some sort of foundational, fundamental versions of forms that were pretty unopinionated. And we could just pretend we have those. What we'd like to be able to do is say, well, a person is made up of a string form, which we could label perhaps with the word name. Obviously, label doesn't exist, so let's actually add that right now. It's going to take some kind of string, and it's going to return not a form of person, but a form of a. It's not going to change the type of the form, it's just going to label it somehow. And then we want to be able to join this. So I'm going to use, I don't know, we have so many operators to choose from, but I'm going to steal this tilde operator from certain parsing libraries, and I'm going to want to join this with another string, except this is going to be labeled email address. And lastly, we're going to join it with an int form that's going to be labeled age. And this operator doesn't exist either, so we're going to create one. And what this is going to do is take a second form of some other type, b, and get us a new form of a tuple of a and b. So this is very much like a parsing library, sort of, or a decoding library. And obviously it's now getting increasingly nested to the left, and it is not a person, but that's okay. What we can do is we can wrap all of this and call map on it. We might want a map function that we can use to access this name, email, and then age, and then accept these and build a person out of them, name, email, age. So we should be able to map over it like this. So I can create a method called map. That sure would be swell. So this is going to take some other type b and a function going from whatever the a type is, which is in this case a nested tuple, and it's going to return us a form of b. This looks pretty complicated and crazy, and we're just making type signatures, but it's actually not going to be too impossible to do this. There is, however, one detail, because this isn't quite the same semantically as a decoder or something where we're going to compose decoders and get back a decoder of tuples and then be able to just cleanly map over those, because this is actually bidirectional. We want to both be able to make changes to our form and have it update some variable, but we also want to be able to make changes to the variable and have it update the form. So the mapping that explains how to go from a tuple to a person isn't quite sufficient. We also need to know how to go back from the person, such that when we change our person variable here, that these changes can properly percolate back down, back into the form field that they represent. We can abstract over this with macros, or at least make it free using a macros for case classes. But when we do it by hand in this first stage, we're going to actually have to have a bidirectional mapping. So in something sometimes called as an invariant mapping, I'm just going to use an X here for sort of cross map. I've seen this before in, I think, what is the codec library? Scodec? I forget. That doesn't matter right now. So yeah, I think it's scodec. I'm going to make a method called xmap instead. Or rather, instead of doing this, I'm just going to extend this thing. So we're going to actually have a way to go from A to a B, and then also, or maybe I should call this 2, doesn't really matter, and then from a B back to an A. We need to go both ways. So I accept this as another argument, and the B in this case, I can just annotate this so it's not confused, is going to be a person, even though it should be able to figure that out, but it didn't. That's okay. So now I'll take a person. So I can say case person, which is the name, email, age. It is annoying to do this, obviously, but it unfortunately is necessary at the moment. And then I'll make the nested tuple that we started with. And it all compiles. So this is kind of going to be the first version that we want to go for. And then if I go down here, we have this main form here, but instead of doing main form, I'd like to be able to comment this out and replace it with form.example, and then call render, and this would accept a variable. So a variable, and where's the person var? There it is down there. I should probably make this a lazy val at this point, but everything is still going to explode. It's probably giving some errors now because these are all question marks. Maybe I'll just render them side by side. No, it's still going to explode. What am I doing? I'll comment that out for now so we can keep our goal in mind. But yeah, we want to make this render. So we have a lot of tasks ahead of us. I think the best thing actually to do is to start simple. Maybe comment this out. This is our ideal API. And let's just start by implementing string, because that is probably the easiest form. So we'll make a new form of string, and IntelliJ is pretty helpful, even though it adds some strange nesting there to the types, but that's okay. And what we need to do is make an HTML element in here. So let's use an input, just as we had before. And we can get the value by taking the variable, and just piping that in there. But we also want to update the variable. So we could say on input, then we could map to value as we did before. Take the new value. Well, and actually I think we can also just actually pipe this into the variable as well. Yeah, that's nice. There's some implicit conversion magic going on in here, but it's all very nice. Thank you, Laminar. And I'm actually also going to wrap this in this thing called controlled, which is going to make sure that these don't go out of sync, or it's going to give them, I don't exactly know what it does. It's a new feature, but it prevents some weird edge cases. So by wrapping these, it's made particularly for this situation, so I'm going to use it. I forget the exact details. And for our int form, actually what we can do is we can just use the string form and call xmap on it, and we can call toInt to go one way, and then we can say, toString to go the other way. And that works too. Of course, we haven't implemented xmap, so that might be a good place to go next. And this might be kind of confusing to do this. So let's just start by getting some types out of the way. I'm going to make a new form of B. That's what we need to create so we can think through how to get a form of B. We actually want to use the render method of the form that we've called xmap on. To think in this case down here, we had a string form which actually defined the HTML element here, the input that we want to use, and it has the logic of updating the variable. So we want to use this render function. We just sort of want to change its output and input. So the strings render function is actually going to be this outer form's render function. So we could rename this so we don't get this shadowing, because in here the word this is going to refer to this new form, so form B, but we actually want to refer to this outer form, so we'll call it self. And we can call self.render. But in order to call this, we need a var of A. Luckily, Laminar most recently added a very cool function called zoom, which allows you to map sort of in that same invariant way between two variables. So I would like to zoom from a variable of B to a variable of A. So by specifying that here. First, the in function, as they call it, is going to have to go from B to A. Well, that's our from function. And then our other function is going to be 2. And it also wants an implicit owner. And to save ourselves a headache, I'm just going to do something a little hacky, and inside here, make an implicit val owner and call unsafe window owner, which I think is always around and available. This isn't so nice, but it's going to be fine for our example. Maybe I'll clean it up at the end, but I don't want to spend too much time on the boilerplate it's going to take to fix this. Not much boilerplate, but just a confusing element that we should be able to mostly forget about for now. Okay, so that was probably one of the harder ones. Let's do label next. This is going to be very easy because it is going to be a form of the same exact type. So we're really actually going to do almost the same thing. Let me get rid of this here. But we can wrap it. We can make a div, and I can use that little, what did I call it? Input group, I think, or form group. I'll figure that out. Then we had a label, which I can use the string. And then I can delegate to the other render method, self.render, and we have the variable of the right type. And oops, label is actually the Laminar function I want, so I'll call this labeled instead. I'll have to change this down here as well, labeled. So that's pretty simple. Last of all is this tupling operation, this little tilde operator, so we can make a new form of A and B. Why are you doing that, IntelliJ? And for this, even though it's not going to be the nicest thing, I will add this little intermediary div. And basically what we can do is we can say self.render, which needs a variable of A, and we have a variable of the tuple of A and B, so we can use that zoom function again to go from a tuple of A and B to just B, and we can do that by calling _2. And then in order to go the other way, to go from a B to a tuple of A to B, we'll have our B here, and we can actually use another function on variable called now, which might be cheating a little bit. This will get us the current value, so we can pluck out the current A and tuple that up with the B. What is the problem? Also, this got it backwards for some reason. I actually want to use that.render for this one. And then for this, for self, we want to use 1 to get the A. So sorry about that, I got it backwards. So this will be the A. And we want to tuple up the A with the old B, so getting a little convoluted there. Okay, and it all type checks. It's not the prettiest code. We could even make it uglier by turning these into underscore parameters, so that's a sin right there. But now I think our little example might compile. Let us see if we did this correctly. Oops, I forgot to write labeled here. But besides that, everything looks good. So let me go down here and swap. And it seems to be working. That's awesome. And we can click on get older and it actually works. We have this bidirectionality. That is successful. So we made this little mini form combinator library that was not too hard to do. Obviously it's not so feature complete, but it's not so bad for 8 minutes of coding. And now for the final step in our journey, we're going to import a beautiful library called Magnolia, which allows us to do type class derivation. Magnolia actually implements all of the scary macros that we need. We just need to provide it an interface, telling it how to convert inductive definitions of our type class into a new definition of our type class. What that means is that at the bottom of the world, we'll have some base implementations of form. For instance, we already have one for int and string. I've made these implicit. And as long as our case classes are comprised either of other case classes, which we can derive, or these fundamental, foundational, atomic instances like string and int, and we could make one for Boolean that used a checkbox, etc. These are pretty general to write. It would then inductively find these definitions and then allow us to build our new form out of them. So let's just dive in and see what we need to do. There is a structure that Magnolia expects. So I'm going to write something called derive form, a new object. I will make a type called type class of A, which I will set equal to form of A, as that is the type class we wish to derive. Next, I'll need to make a function called combine, which will be parameterized by that type. And it's going to accept something called a case class, which has some parameters itself. The first one is going to be the type class we're deriving, and the second one is going to be the type we're returning. And this should return an instance of form of A. So let us make a new form of A. Let's just start implementing this. So the goal is to, given something called a case class, which has some information that Magnolia has generated, gathered at compile time for us, we're going to create a new form for some given type A. So this type A would be a person, given our example. And this case class is going to contain some information about our person, such as the parameters that it has, their labels, as well as their inductive, their own instances of the type class. To just explore that for just a moment, I'll make a div here, but let's just take a look at case class. We'll see that there is a sequence of parameters, and a parameter, if we just pluck one out of here, has a whole bunch of different features. It is something called dereference, which given an A, i.e. an instance of our person, perhaps the one that we can get out of variable, we can actually get the value that this parameter represents. So this parameter were, say, by looking at parameter label, if this were the name of our person, then by calling dereference and passing in variable.now, this would pull out for us, well, this path-dependent type here. This would be the string representing the name of whatever person that was. But we're not going to worry about that. We're just going to look at some of these high-level methods. We're going to see that we have a label. This is perfect. We can use this for generating the label. We are going to use dereference to pluck out these values, but we're going to use it in concordance with this method on the case class itself called construct, which is a pretty strange one. But what this does is it's going to give you each parameter. You're going to give it a function, rather. It's going to take each of these parameters, so a parameter for the name, a parameter for the email, one of these types that has the labels and all that, and this dereference capability. And then what you have to do is you have to return the type that the constructor expects. So basically, if we just wanted to rebuild this person, we could do that parameter.dereference variable now. So what this is going to do is for each parameter in the case class person, it's going to give us a name parameter, and then we'll use that to pluck out the name from the current person. And it's, it's some specially constructed kind of unsafe function. We have to implement it correctly, otherwise it will explode. That will then get us back basically the same person in this case. We could do more clever things in here, which we will later, but those are the three sort of tools that we're going to need for this. We're going to need the ability to build up a value of A, and we can do that with a pairing of construct and dereference. And then we're going to also want the labels of the parameters. So it's a pretty powerful library. We're not going to explain it too much more than just using it, but the docs are quite extensive, and looking at some other examples will help to diff out what is important and common. So yeah, let's just get to work. We need to build ourselves a form. So we're starting with a div, and then what we're going to do is actually take our case class, get the parameters, and then map over this. So we're going to try to create a list of HTML elements. And in Laminar, you can take a list of HTML elements and then render them flatly. So for each of these parameters, we have an instance of type class, which is the form for whatever parameters type. So if this parameter were name, then this p type here would be string. So this is a form of string for our name type class. So it would have gathered that because we have that implicit string form, so it should be able to find that. And then we can call, well, first labeled, and then we can use the params label field to get a little, why did that happen? That's cool looking, but we don't want that. So we still just have a single labeled form, but we need to render it. That would be the next step. And so we need to give it a variable of the type of this parameter. So we're going to do the same thing we always do, which is zoom in on our variable. We'll call zoom here. And so this first one is pretty easy. We're going to get in a value of A, which is going to be in our concrete instance a person. And then we can do that thing that we were talking about. We can say param.dereference of A, and it's going to pluck that out for us. So that should work going one direction. But then we need to handle going the other direction, which is going to be a little more complicated. We're going to get one of these param values that we're not really sure what type is even in there. And then we're going to want to build a person out of this. And this is where we're going to use case class construct. We can't just use copy like we did before because we don't really know that we're dealing with a concrete person, but we can use construct here. And we can take the parameter that this gives us, see if it's equal to the original parameter. If it is, well, then we can use the value that we received. This will be the new value. Otherwise, we can do the same thing that we did previously and call dereference, except since we don't have an A in here, we'll call variable.now. And I know this is some horrifically ugly code, but the good news is we're nearly done. The last thing we need to give this is that ugly unsafe window owner thing again. And this compiles. I don't think I've screwed up anything, but we will see what's going to happen. Next, we'll make an implicit definition. This is the last step called gen, which is going to return us an instance of form of A. And here we're going to use a macro. We're going to say magnolia.gen of A. And this is sort of the last piece of the boilerplate that we're going to use. Of course, in order to get this to work, we can import the language feature experimental macros business there. And now let's try it out. Let's go back down to example. Let's call this example manual. and make a new example that has a form of person, which is gathered by calling derive form.gen of person. And it just refreshed, and it looks the same. And I can type, and I can call getOlder, and I can change the age. So it's kind of hard to tell if this is working, or if it isn't. Let me comment this out. Go to person, and let me just add something like a favorite food, which I'll also make a string because we've only made string and int here. And I'll say ground beef, which isn't quite true. And voila, it has appeared in our form. Ground beef, actually like beef bourguignon. That's yummy. We can make ourselves absolutely ancient. We were able to just change the structure here and have it work. Let's do something slightly more interesting by making perhaps a dog that will have a nickname, and then maybe a loudness, which might be an integer. And then we can give a person a dog. I'll need to add one to our original definition. So I'll make a dog named Crunchy and make it very loud. And here we go. A dog section has been added. Its name is Crunchy. We can change the dog's name to Spot. We can make it quieter. We can still make ourselves older. Everything works, and everything is merely derived from the shape of this form. So that's kind of cool. Clearly there are some issues when doing derivation like this. For instance, favorite food has now been smushed together. There's no space. So we could either sort of go back to where we derive this and try to flatten out camel case labels and turn them into multiple words. Or we can make this configurable. Magnolia adds the ability for static annotations. So what we could do is go down here and do something like label and give it favorite food and have that work. Obviously, we'd have to create one of these. This is in the docs. I don't really want to get into this right now because it's going to make our derivation function slightly funkier, but it's actually pretty straightforward. Essentially, you just get a list of these annotations at compile time. You can match on them and then switch up your behavior. So if you find a label annotation, you can swap out the default param.label using the value in that annotation and do all sorts of other clever things. There's a lot we could do. We could add validations. We needed to give it sort of an original person here, but it might be nice if you didn't have to give it a default value and instead perhaps just a variable of a option or some validated property of this. That obviously makes everything a little less trivial, a little more complicated. This is actually already pretty useful, and it only took barely 80 lines of code if you smush it all together, actually even less. We could add more types, for instance, checkboxes and multi-selects, and do all sorts of clever things. You could really flesh out this library and make it really cool. But it's kind of awesome that this is relatively easy. And if you're interested in what my vision of this stuff is, I gave a talk last year at Functional Scala 2020 called Stockholm Syndrome Escape Velocity, where I do less of this in-depth coding, but more looking at what happens if you derive everything. How happy can you become as a developer? How little work can you do before just clocking out and designing NFTs all day or whatever? I hope that was useful. Thank you very much. I now recede into the darkness. Until next time, take care. Scala.